Right, so good morning everyone. So thanks for coming back to this RoboCup at Home Education online classroom. And today we are going to start our third class, which is today we talk about this robot software development. Right, so the first part I will introduce a bit about ROS Basic, some very important tools in ROS that you are going to use it frequently in your uh, coming development. Right, most of all. Right, but before that, so let me start with okay. So okay, doesn't matter, right? So we will start with that is arrangement. And we can talk continuous this time, so don't worry. And you don't need to log out, so just use more time because the live demo might take some time. So let's see how it turns out later on. But the arrange tell you in a lecture form that what is ROS and what are the basic things that you need to know. Then the second part, after 11, hopefully, I will show you the demo. And by that time, I hope you have your system ready and so that we can do the hands-on together, right? And we have the same Zoom link today, so you can use it, right? So we can use it for the whole 2 hours, don't worry. To remind you about previous assignments. So previously last class, I show you some assignment that I recommend you to complete, which is important thing is that the first thing is about the system, the development system, which is your laptop. So I have some guides on how to do dual boot, how to install Ubuntu, how to install ROS Kinetic, and so on, and also the GitHub stuff. So I'm not sure like how much you have gone through, but hopefully like by today you have the system ready with you. Yeah, because that is very important so that later on when I do the demo, you can follow step by step, or you can have a look, then you can try on your laptop to make sure that you have the same effect after this. Okay, so that is the hands-on exercise is very important so that you can remember the very important basics that I'm going to show you today in today's class, which is the publisher and subscriber, because that is the basic communication in ROS, and that is the basic building block for you to uh, create your application after this, right? Then for the GitHub, yeah, it's optional, but I do recommend you to also go through the GitHub thing, right? The reason is because to let you learn a new way to manage your uh, source code, yeah, right? Okay. Then, okay, of course, I show you where is the tutorial for beginner level, but today actually I will start one basic thing, which is also covered in the basic ROS tutorial. So which is how to create a package. Then after that, on the package, how to create nodes that have the function of a publisher and a subscriber and how they can communicate together, right? So okay, so that is the previous assignment and also the prerequisite for this today's class. Okay, so first thing, what is ROS? So I'll give a very general overview on ROS because ROS is a very big system that it got many details that need to be explained in order for you to fully understand what is ROS and how what is inside there and what you can do with ROS. But for today's class, I just want to give a brief introduction about what is ROS, particularly on those tools or those things that you need to know in order for you to start develop a service robot or service robot application or AI application, right? The reason why I'm not focusing on teach you how to use ROS rather than make you have the concept that use ROS as a tool to solve your problem. Okay, so that is always the mindset that I try to uh, share is because I feel that other than ROS, there are actually many other tools that you can use for your service robot development. Okay, so don't just limit yourself and try to do everything with ROS. Yes, but ROS actually give you a lot of tools that you can use. So just keep your option open. Okay, so basic thing that is easier for you to achieve, you can use ROS to achieve. But on the same time, you might want to learn something that is outside ROS as well, because you are free to use any tools as long as you're able to solve your problem. Okay, so that is a more important thing because a lot of times people try to struggle a lot. They try to do everything in ROS, and sometimes you need to balance out because the effort that you want to create something that is not exist in ROS will be quite difficult for you to create that component in ROS. So I'll show you the way along these classes, how to actually use ROS and also use other tools. For example, you have Python SDK, Python projects that you want to put in, or maybe not Python, but other things. You want to incorporate with some tools from Microsoft, from Windows, and so on. So how you want to put them together? Yeah, because if you think that you want to do everything in ROS, then you actually have limited yourself to some choices and put out some other potential things that you can use, which is much easier or better effect for you to solve your problem. So the mindset over here, before I start to tell you what is ROS, is like I will prefer you to think ROS as a tool. Okay, but of course, I can say like 80% of all the developments that I'm going to show you will be inside ROS, but I always prefer you to have an open-minded, especially now we have a lot of open source tools and API available that you can use. So try to be creative and use yours as a tools, and also think of other tools and how to solve your problem. So the important objective is how to solve your problem, right? Okay, right. So let me start with introduction. So ROS, the name, robot operating system. So it is, although the name is operating system, but it is actually not an operating system. Okay, yeah, because when you install ROS, you actually install ROS inside your Ubuntu system, right? So Ubuntu system, or the Ubuntu itself, is the operating system. So it is the operating system that operates your machine beside Windows and Mac OS and so on. So there are many Linux distro that you can use, but over here, for simplicity and also user friendliness for beginner, so we use Ubuntu to start with your development. Okay, so hopefully now you have some phase, you understand what is a terminal and so on. Okay, so from there, that operating system, so we put in ROS. So for me, I understand ROS as a framework, okay, a software framework that pull all the tools, software tools. For example, like you want to do image processing, then you want to use OpenCV, you want to use navigation, then you use the G mapping and stuff. So for speech, you want to use speech recognition, package module, and so on. Right. So there are many things that you want to put things together in order to build your robots. And ROS as a software framework that integrate all these things together. Right. So like a software framework for me. Okay. And inside there, it has several very distinguished features that make it so popular in robotics community. Okay, so for example, the first thing I say, software. So what is bundling is the process management, the inter-process communication, the device driver, and so on. So when you want to develop a robot, you need to deal with many layers of software. Okay, so for example, over here we have many processes. So for example, like you have one process that deal with your hardware, for example, your driver, so on. Then you have another process that deal with your calculation, your algorithm, your decision making, and so on. So you have of this because you don't limit yourself to just one component. Maybe you have several sensors, you have several actuators, and so on. So talking about many devices, many process. And inside there, you might also have a lot of different calculation algorithm. For example, when you have a control system of your wheel and you need to do a decision making, like where to go and so on. So all these processes, how they communicate with each other. Right. So ROS try to sort this thing out with you. So it has a very how to say, systematically. In old days, when we don't have ROS, we need to do all these things one by one, and the complexity add on when all these things are in different languages. For example, I have a driver that is written in assembly language, and I have another algorithm that calculates in C++, for example. Then you need to, like, how you want to interface all these things. So ROS try to pull this thing together, so they have a very systematic way to do the communication, right? So this is the software framework that is very important for us when we want to build a robot system that need a lot of communication or coordination between all these processes. Okay, so that is the first very important features in ROS that make all this thing possible for robotics development. Okay, then the second thing about ROS is like it comes with a lot of very powerful tools that previously you need to use third-party tools, or you need to build yourself. For example, when you want to do simulation, then you use another simulation software to do it. Then whatever hardware that you build, whatever model, you need to build again in the simulation in order to do your simulation. But ROS comes with its own simulator, which is called Gazebo, that I will show you along the way in this class as well. When we do the navigation, we use the simulator to do the navigation. So it actually gives you how to say, a seamlessly integrated between your robot control and also your simulator. Because whatever that you develop, for example, your control algorithm or your source code that you develop, run your robot in simulator, right? The same control system, the same all the source code you can use can directly implement in your hardware as well, right? So that is a very nice tool to have. Then the second thing is the visualization. I think we use this thing a lot. Okay, when you start to develop your hardware or your application, is because we need to deal with a lot of data. Okay, when you develop your robot system. Okay, so what kind of data? For example, you have sensors. So over here we have, for example, the RGB sensor, the Kinect sensor. So it gives you a lot of color information, RGB, and the correspondent depth data, right? For all the points, so you will have the point cloud with the colors, image, and so on. So if you receive the raw data, you only see a lot of figures, okay, a lot of numbers and so on. So it don't make sense, like, for us how to visualize this data. So in ROS, it comes with a very nice tool called RViz that can let you see this data in 3D and not just the sensor data, it also has the robot model, for example, and also some other calculation result, for example, like your path, your map, and so on. So all these things can be visualized in ROS. And these tools is already there for you to use. Okay. Then about graphic user GUI. So of course, we use the Qt system to do the GUI, but ROS don't really a lot on GUI for operation, right? But for a lot of debugging tools, for example, like programming tools, development tools, you use a lot of GUI. For example, your visualization itself, it needs the GUI for you to see the thing. And then you can, of course, create more GUI, but most of the time, the development that we do, we don't really use a lot of GUI, but of course you can use that, right? So we have the GUI tools in ROS that you can develop. Then the data logging is very important for you to debug all your development, especially when you run, you have some bug and you want to debug your operation or debug your processes. So you need to know like what happened along the way. So all the data is logged nicely in ROS. It has the ROS back tools and so on, so that you no need to actually recreate your data logging system in order to see all those figures. Okay, right. Then the next thing that is important that ROS provides us is this, what we call the capabilities. So this, I think, is very, very important compared to other software framework, is because a lot of times we need to rely on certain capability because we might just focus on certain expertise. For example, for me, I study about human-robot interaction. So I have no idea how to do navigation. I have no idea how to do image processing and so on, right? So a lot of all these things, but when you want to build a service robot, you need an integrated system. You need everything work well and integrate well in place, right? So for example, you want to build a service robot that help people by taking stuff for you, for example. Then you need the speech, you need the visual, you need the navigation, you need the arm, and so on. So you need everything in order to build a complete system. So for me, how I can achieve all those, especially those things that is not within your expertise or within your interest. For example, like you have no interest to build navigation, for example, you don't know about mapping and stuff, and it is not very important for your research work or development work. You still need this thing, is because like you need the navigation part to move your robots, right? So in ROS, it really provides us a lot of this control, planning, perception, mapping, manipulation, this kind of capability. Is because it is a system framework that a lot of, for example, like people that good in control, they contribute their work into ROS. Then it open sources, then we can use the control system. So the same thing like mapping, perception, and so on. So a lot of people, for example, good in image processing. So it create a lot of nice tools we put in ROS and make it open source. And yeah, so you have all the capability that you can use to put in. So until today also, I try to understand more and more, although I've been like using the navigation for so long, right? So this capability is very important, that when you use ROS, you actually open up yourself to a lot of others expertise that people share this, how to say, their research and development work in ROS framework. Okay, right. Then of course, lastly, what makes ROS success, I think, is the last one, is the ecosystem. So I think similar things like ROS actually exist long ago. Okay, personally, when I was in Japan, so I know there was one system that is very similar to ROS, although there are some differences, but very similar to ROS. But what determines this system to become powerful or become uh, something that a lot of people will use is how the system is accepted by many people. And then many people come in and share their work. That's very important thing, especially for open source software. Open source software is like you need a lot of contributor, volunteer contributor, to pour in their work to make this thing a success. And ROS actually not only it create a lot of things, for example, like this package organization, software distribution, documentation, tutorial. Although all these things not really just the work of the ROS creator, the teams that created ROS, but an open source contributor that try to make all these things a success. So you have a nice package organization, which is we use the Ubuntu system, the similar like how you download software in Ubuntu, you update software and so on, the software distribution, the documentation. Yeah, documentation and tutorial is very important, right? And we know that because it is an open source, so we don't have a teams that are dedicated to do all these services. So all the volunteers in the open source community, they actually document their work nicely, they write tutorial. And for example, I, as one of the people in this community, I try my best to create this class, I create the teaching materials and so on to spread how to use ROS and so on. So this is one of the efforts similarly with a lot of people that benefit from ROS and try to put back their effort to make this thing happen. Okay, so the whole ecosystem that able to pull a lot of people from all over the world that makes this system success. So this is ROS. Okay, I will be very brief on this. So distributed system. So it is peer-to-peer distributed. So which means you have things that run on different machines. Okay, you can have things that run on different machines, and then it is not a monolithic system. For example, like when previously you develop a robot or you develop an application, you write a single code that have everything together. But in ROS, it tries to have a different concept that I will show you after this. Okay, I'll show you after this. It has a different nodes, small nodes that work together, right? So this distributed idea is so that you have all the nodes that run dedicated work in a very simple form, but when they work together, you can create a very complex system. Okay, then they are very, although it sounds tedious to do that, but it got a lot of advantages to do in this way, which I will introduce along the way when I introduce the ROS basically. Okay, right. Then multilingual programming language I need to know and so on. So for ROS, it actually can be written in many languages. For example, C++, Python, MATLAB, Java, and so on. So it can, all the module of all these different languages can actually work together. So you have a very, how to say, a unique compilation system that try to pull all these things together. But mainly you will deal for the exercise of all the example that I show you, mainly they are written in Python, okay? But previously I can say like maybe 3 years ago, it's about half C++, half Python. I started learn most of the code are written in C++, all right? But today, after 10 years plus, after 10 years, the trend have changed. And now maybe when you search, you might able to find like 80% and above the code or example in ROS are written in Python, right? But of course, it can actually coexist. So we use C++ for a lot of basic things, for example, like control hardware and so on, interface hardware. So those are the code that still run or written in C++, but majority, for example, like when we deal with high-level control system motion making, we use Python to do the programming. Okay. Then lightweight, free, and open source. Okay, lightweight, I'm not so sure because like some of you might feel that ROS is very heavy, but it is not really very heavy in terms of the whole system itself. So you are not running a very big system, but when you run the nodes, when the node might be very thin, I mean like, yeah, very small, but you need to run a lot, then it becomes heavy, right? So, okay, lightweight is something that is up to which perspective you view the system itself. But for me, I think, yeah, it is good enough. Especially when you compare the complexity, the complex of the system that we're going to run, you might feel that, yeah, it is able to run on just a normal machine, okay? Then free and open source, okay, this one no need to tell, everyone can understand, right? Okay, so you have installed everything and you don't pay anything and it's free for you, okay? Okay, so let me start with this. Okay, so I will explain, so for the first half, yeah, I will explain this through one cycle. So which means the way how I conduct this class will be I will explain the theory part, okay, to tell you what is ROS and what are all these basic things, the fundamental concept of a ROS. Then after that, I will show you this thing in the hands-on, okay, in the hands-on. So so from when you want to start ROS, you need to start the core, okay, which is over here we call it the ROS master, right? So we call it the ROS master. So over here, the very basic things that in order for you to run ROS is you need to run this what we call ROS core. So over here you can see this when you open up a terminal. So the way how you run ROS is always okay. You run the command, which is a command line interface. So you run the command, you execute ROS thing, right? So and this ROS master act as the main part or the main component in ROS that communicate or coordinate all the other sub node down there, right? So this is very important. So always you need to have this master running behind because it coordinates all the node down there, right? Then you need what we call the nodes. So what is the concept of node? Node is like a single purpose executable program, right? So individually compile, execute, and manage, right? And organize in package. Okay, so what does that mean? So when you look at this graph or this diagram, so we have a ROS master, and then we have all the, so you can consider this as one process, okay? This is the main process. And then we have another one, which is node 1 and node 2, really coordinate all the node down there, okay? And then the way of communication is like this. All right. Of course, this also communicate like this, but they have to go through the master. They have to register to the master. So master will coordinate all the nodes. Okay. So what is this node? Okay, so node is a single purpose executable program. So let me pause this a while and show you a comparison. For example, when you want to build a line follower. So I guess everyone know a line follower here, right? So when you want to build a line follower, so three important components that you need is first, you need the sensor to send the line, right? So you have the sensor to send the line. Then once you have the sensor information, you need to do some logic calculation, right? You need to have the logic. The logic maybe can be very complex or maybe it can be very simple. For example, when you see the line, you turn left for your left wheel, for example, all right? So turning to the front or turning backwards, okay? So that is the decision making. Then you have the third component, which is your actuator, the motors, for example, right? So when the motor receives the information from the logic, which is the calculation said, okay, you need to turn left, then the motor will start to turn left. Or maybe you have a motor control, which is to control the speed. So you will say that, okay, you turn left in this RPM, right? So for example, so you have these three components to build your line follower. Okay, so in your normal programming, for example, you are using a microcontroller, then you write a C programming to control this thing. So it's very simple. So you write a logic thing like, okay, you get the sensor data, right? So you have a variable, you get the sensor data, then you pass the sensor data to your calculation or your logic. For example, if what, then what, or while, or whatever things that the logic that you write for your calculation. Then you pass the result, which is supposed to turn left or right, to your motors, right? So you write everything in one single C programming file, then you run the whole thing. You compile, you run the whole thing, and then it works for your robots line forward. Okay, but if you want to do the same thing in ROS, it will look like this. Okay, it will look like this. So the three component will be divided into three nodes. Okay, to make it simplicity, although the actual implementation might not be that, but for example, I will separate these three into three nodes. So the first node is the sensor node. So what the sensor node do? Very simple. When I run the sensor node, it reads the data from the sensor. So for example, it will connect, okay, it will run the driver of the sensor, then it will connect to the driver, then, it will run the driver, then it will connect to the sensor, and then whatever data that's come in from come into the sensor, it will process and it will give the nice or filter or process data of the sensor node, right? Then we have another node, which is the calculation of the logic node. Okay, so this logic node will keep always listen to the sensor node, okay, for information. So the sensor node tell, okay, I saw the line, or no line, or line or no line, right? So the information is maybe 1 and 0 and 1 and 0 and so on, right? Okay, so the logic node will do, okay, so if I have a yes for sensor, then I will say turn left. It will say turn right and so on. So the logic node is very simple. Okay, it just perform the logic if else. Right. Then the third node is the motor. So the motor will run the motor control or whatever driver. Then it will turn the motor. Okay, it will give the signal for the motor or the motor driver to actually run on listening to what the logic node say. The logic node say, okay, you must turn left. Then it receive the order and turn left. If you receive the order, turn right, then turn right. Okay, so that three nodes. And when you put all these three nodes together, it will become your line follower, because the first node always get the sensor data and pass the data to the second node, which is the logic. Then the logic node, based on whatever information from the sensor, it will give the result. Okay, it will give the instruction, okay, based on the logic. Then the motor node always listen to the controller, the logic node, and try to move the motor, right? So with that, naturally, you have all the whole system by using this three nodes. So these are the difference. Okay, so maybe you can understand. So let me explain the concept after this. So it communicate to each other. So just now I said it listen and it's also it pass. And pass is by a mechanism that what we call publish and subscribe. Okay. So when node 1 want to pass a message, which is the data, to node 2, it will publish the data into a topic. Okay. So let's imagine topic is like a chat. Okay. A chat window, for example. Okay. So chat window topic called, for example, sensor data. Right. So if node 1 is sensor node, node 2 is the logic node. So the topic will be sensor data, for example. Then node 1 will publish, which is every time when node 1 receives a data from the sensor, it will publish, it will push the data into this chat, into this topic, okay, into this chat window. So which means when I see something, I will type this data onto the chat windows. Okay, so I publish to the topic. Then the node 2, which is the logic, will subscribe, which means it will listen to this, which means for me, for example, I will listen to this chat window and see if any data or any message appear, right? So the process of looking at the chat windows, which is over here, we call it, the node 2 is subscribed to the topic. Okay, then all these things will establish the communication between node 1 to node 2. So this is how the message or the data is passing through from communication in ROS. Okay, although you might say, okay, why we want to do so tedious to establish this single live follower code is like you just pass a message. For example, you say sensor data equals to something that you get from the sensor. The logic will do some operation with the sensor data and pass it to the wheel, right? Okay, you will say that is very simple. But let me tell you a scenario. For example, over here, sensor, for example, right? You have sensor 1, 2, sensor 3, sensor 4. And all these sensors actually use the same driver, and how they pass the message and so on is the same, right? Okay, then your logic have to listen to all these sensors. So every time when you want to add a sensor, you need to modify the code. You need to modify everything because the logic node have to listen. You need to add to listen to. So you need to change the whole programming, right? And then when you want to remove one sensor, you need to change the code as well, right? Okay, so the same thing, the logic also. So maybe you have different set of or different rates. For example, for a live follower, you have different rates. For race number 1, race number 2, you want to have different logic. Every time when you want to change your logic, you have to rewrite everything, including communication with the sensor. So that makes all your things have to redo everything every time you change this thing. But when you do this communication in the ROS way, you no need to change everything. Okay, for example, in over here. So the idea of in ROS for this communication is you can establish the publisher and subscriber without the opponent, which means you can publish without a subscriber, which means when I have a sensor node, I receive a data, I can publish to the topic and it's done. Okay, everything complete. So my sensor node is complete. So regardless whether you want to read the data or who want to read the data or you want to pass this data to logic 1, 2, 3, it doesn't matter. The publisher code or the publisher way of writing is still the same. So it is very independent. It is not dependent on whether you need someone to actually receive the data in order for you to write your publisher, right? So that is the flexibility. So same thing with your subscriber. So when you want to change your logic or you want to change your data, your sensors and so on, you don't need to do anything. Okay, you just need to modify yourself. You don't need to modify other things. Okay, so that is the independency and also reusability. Because once I write a sensor node, which is I have a way how to read the sensor data from the sensor and publish out, which is usually this work will be done by the manufacturer of the sensor. So it just gives this code to you, and automatically when you run this code, you already know how to read the sensor data, and then you already have a very nice process data that you can use it for your application. So that is the idea. Right. So the same thing for the logic is like if someone have written a very nice, for example, like mapping code or control code or whatever code, you can just use it, plug it in with whatever sensor data you have that appropriate for the calculation, then it just works. You don't need to know how the node 2 or your logic is done. Okay. You don't need to know the underlayer and you can use it as a tool. So that is the idea how flexible is this. Then inside this topic is the data. Okay, I keep calling data, but over here, ROS call it ROS message. So it's the messages inside this topic, and these messages it do it in a way that is very flexible. Okay, it can be any format. I mean, like any format that you use. For example, over here it show example like integer, number, double, string, and it can be as complex as, for example, video stream. Okay, video stream in you got like in every frame you got a lot of data, right? And also it can be like a stem, a stem data, which is I show you examples here. So for example, you have you have a series of robot movement. Okay, so you have the robot position, you have the robot orientation, you have the timestamp, you have all this information, and it can be also just as simple as a topic, right? And how you want to interface with different kind of messages or different format, the publish and the subscribe are the same. Okay, so how you want to pass the message and how you want to receive the message, the interface, the way how you do it is the same regardless what kind of data you're dealing with. Okay, so it's very different. You don't need to define, especially when you are dealing with Python, you don't need to define a lot of all these things. So everything done, and you just need to know how to connect them together, right? All right, right. Okay, should I post? Okay, so let me show you example. Okay, I need to run my. So now, if you have, you can also try. Okay, so I another Ubuntu system. Okay, so I have this issue. Try something like this. So this is my Ubuntu system. Okay, you have something like this. So I hope everyone by now you have this system with you. Okay, so I understand that you might have problem to install your robot system. I understand that you might face problem when you install ROS Kinetic and so on, or maybe you are using the virtual machine, so you have problem A and B, or after you install you cannot hear the voice, you cannot connect to the internet, your LAN card is not working, your sound card is not working, and so on. I understand all this problem is expected. Okay, because got a lot of compatibility issues, setup issue, and so on. But please keep this message and let discuss in our Facebook group. Okay, so again, everyone, I saw now in my list, we have about 31 name, and then I typed the attendant list. So please put down your name. And then the next thing I'm going to say is like, yeah, so if you have any problem, okay, so I would like to remind you, if you have any problem you want to ask, if you have any question, okay, you can, of course, you can email to me, but if you don't want, the easiest way is you can post your problem or question in our Facebook group. Okay, so I hope by now you know where is our Facebook group. So we have a Facebook page, RoboCup at home edu, right? Then inside there you can access to our group. So I share all the tips and information there. For example, the video guide and so on. So you can also post but a lot others, how to say, expert. We have many professors in our teams that can help you as well, right? And then they might be better in helping you on all these technical things. So please discuss this and don't worry, because at home education, you think that it's something that you want to ask in private. Okay, you can actually like message us as well. Okay, so don't worry, just use the Facebook group for communication. Okay, which is the Ubuntu system review. Then you already install ROS. Okay, so one way to show that you have. Okay, I hope the text on the terminal is not too small. So if the text is too small or it's not clear, you can't really see the wording, I will assume that, yeah, you can see it clearly. Okay, right. So once you run your ROS core, after you install your ROS core, so last week assignment, you install Ubuntu, whether it's a global system or using a virtual machine. So you will have this system, right? Then you can call your terminal, and yeah, this is terminal. Okay, so just search, then you come up. Right. Then in your terminal, just now what I did is like I type in ROS core. Okay, then you can see. So if over here I can see like, okay, my ROS, the version is kinetic and 1.12.14, right? So it's kinetic, right? Then over here you can see like my another important info point to which machine. Okay, so this wheel is basically my this PC wheel, and then the port is 11311. Okay, so this one you don't really need to care. Okay, it's the communication port, right? So this will be, and this master URL is why we need this is because like different node can be run in different machine. Okay, as long as it is within the ROS network, and you need to know how to configure, but that is another topic. Okay, but just to show you that this show the features that it run across the network. Okay, so if you have this, then everything is okay. So let me put this back. Okay, like this. So I put this thing here. This one I have to. Okay, so I need to do like this. Okay, it's not looking this way. This way. Okay. So I get right. So once I run, the previous one is first thing is you need to run ROS core. Okay, so ROS core, then you get something like this, which is something like this. Then after that, tap terminal 2. Okay, so let me run another terminal. You can run a new terminal, or you can run another terminal in the new tab. Okay, but I way. Okay, so this will show you. Right. So the second thing is you need to raise ROS run. Okay, so ROS run. Okay, right. So ROS run is the command in ROS that run to execute a node. Okay, when you want to execute a node, you use ROS run. And then the node in ROS is arranged into packages. For example, you have this tutorial node, which is, for example, over here we have one package called ROS CPP, ROS CPP tutorial. Okay, so this is the package name, right? So the package is a package of related node within a package, right? So you put all the node that run, for example, a line follower package. Then inside a line follow package, you have the node, you have the logic algorithm, you have the motor nodes, how you create like a project, and you have all the processes inside within this package. Then Talker is the node name, right? Is the node name. So this is the node name for the node that you want to execute. So this will show you something like this. So I have the node running and it right. Okay, so in the second, I will show you how this thing is done in when you run the code. Okay, so what happened when I run the code is like it will start to publish incremental that's increasing, right? So this is the function, and it print out this whatever method. I need to put this in. Okay, I need some space to start another terminal. Okay. Over here. Go to the next one. So on the third tab, you can check. Okay, so first is like you can see I have actually two nodes. Okay, so this ROS node list currently exists in the system. Okay, so we have a ROS out. This one, once you have the ROS call, you will have this. Okay, so this is the overall. Right, so we just run. So right, then you can check, for example, right, ROS node. You can check the info for which is you can see. So you can see over here it said that it is publication. So now new information. Okay, so we have format of the messages inside this chapter is standard message string. It's a string. So this one is a string, and then currently there is no subscription for any of this. Okay, and service this one you just ignore. Okay, you're right. It's within this. Okay, right. Then since you know this chapter, another command called ROS topic. So this one is check all the chapter. Okay, then you get something very similar. Like the thing is, this topic is published by this talker node, right? And then currently there isn't any subscriber. So this information is very important later on when you want to use other people tools. For example, like you use open want to check like which message you can use or which data you can use. This is very important tools for you to understand this. Okay. Right, then we have the type will show you the string, which is over here, is already there. Then you can echo. So echo is something very similar, like to print echo this thing. Then you get something similar like this, right? So the data is hello world and plus. Use Control C. Okay, Control C is to stop the operation. Then another important point over here is this hertz. So ROS and then this chapter. Oh, sorry. Okay. So what is the speed or what is the interval time for the publication? Which means after the first after you publish the first data, then after you publish the second one. So which means how frequent the publisher actually publish the data. So you can see over here the average is not exact time, is because like it is the time later on you will see in the code how we achieve this is the code to make it about 10 hertz, right? So which means every time it will calculate your system resources so that every time it will wait until about 10 hertz time, the interval, to publish another node, to publish another message. Okay, so from here the publisher send more frequent data, for example, like even like 100 hertz or 1000 hertz and so on, depends on your machine capability, like 1 second once or 10-second once and so on. Okay, so we can use this, right? So later I will show you, especially you want to synchronize between your sensors and also your processing. Okay, you need to have sensor that is fast enough for your processing. If your processing is asynchronous problem, right? Okay, now let me use another terminal node. Okay, so now we need to run a new node. So okay, just taking back. Okay, so we'll try this. Okay, so let me put it here. To run another new, sorry, I want to run another new node. Okay, right. So what I do, ROS run and then ROS CPP tutorial. So you see they are in the same package. Okay, then listener. So this time we are running the listener, and you can go here. So now if you check, okay, now if you check ROS topic list, you can see now we start with node first. ROS node list. And Hawker. Now after we run the listener, then we have executed, right? Then if your topic list, okay. Now you can see just now it said subscriber none, but now the subscriber becomes the listener. Publish the type is string. Okay, so it's string, and then it is published by this jar on the same machine. Although they are in different port, but they are on the same. Right. So now let me stop this. So you see, once I stop this, this thing stop. Right, so the last one was this one, right? Okay, so it stopped. It don't receive any. Okay, but what I said, when you when you have a different node or a different way to publish the message, this thing can still listen, right? So because it is independent. So let me use a tool which is manually from terminal. So the command is publish function. Okay, so you publish to this chapter node, and then your data is in this standard string. And then you need to put in this. Okay, so you just type it and it should be out, right? So over here, I need to type in, for example, I put my name. So for example, if I send this, okay, so let me show you. So if I send this, you see, it appears here. So which means the listener actually catch me because I never stop my listener. So the listener actually still keep listening, but because the talker stop, which means it keep on listening until another one, which is me from another node, actually send in manually a data into this chapter topic and it will save. So which means the listener is actually working. So that is how. So that actually concludes that how I pass the message from node 1 to node 2 by using the publisher and subscriber function. Okay, right. So that is the concept of publish and subscribe. Then, okay, so there are many other things in ROS but let me just give you a brief how to say introduction, but you might not using now, but you might use this. You might be using all these things afterwards in your development. So just a brief introduction. Don't worry if you cannot remember. Okay, you can always refer back. So one very important things that you will use it after this is the launch file. So I can actually run the talker node and the listener.launch. Okay, so I can put these two nodes together and then run it in a single command, right? So the way how to run it is ROS launch file, which is stop with the dot launch, okay, the end with dot launch, and then this file inside there, they will have a definition, which is talker node and the listener node. Okay, so how it is defined, the launch file is in XML format, so it will have a definition like this. But don't worry, okay, for the current moment, you're not using this, so don't worry. It's a package, where is it, and what is the output? The output means whatever, when you run the node, it will have some output, which means, for example, you have the print screen or whatever. Sorry, you'll print the output and so on the screen, so you can define, or maybe you can just don't print out whatever output it is. Okay, so this is just for information later on. Okay, right. So the launch, and this one is for your information. You can see it after this. Okay, you won't be using this for the time moment. I've just introduced you that you have this, right? Launch file and so on. Right. Then next thing is we have the Gazebo, and this is something only when you, I think you already installed. Okay, once you install ROS Kinetic, you should have this, and then you have all these things. So this Gazebo Simulator is a tool that later on we will use, but not so soon. Okay, because after this we'll do the speech, then we'll do the vision, then only we do the navigation. During the navigation, you will use the simulator because you will control the robot within this simulator. Okay, because you don't have physical robot, so you will use the simulator to provide you a robot platform for you to do the control. Particularly over here, we learn about the navigation, how to build the map and how to do the navigation, right? Okay, then before I end this session, so just to tell you, there are actually many things that I can introduce you that you might need to know, but I'm not going, I can't finish within this session, or I need to have more session to introduce more about this role. So these are a few things that you might want to know. Okay, so the first is like how the package. So just now we run the CTP example, right? Okay, so we have this what library you can use and how to call it, the visualization, TF, this one and this one. So these three, the TF is about how the structure or the definition of the frame of reference inside ROS. And then RQT is the user interface, the GUI. Okay, URDF, SREF, this one, this SDF, UOEF to define the robot model. And then we have the ROS time, which is just now we use the hertz and so on. And ROS back is about how you can record all the data and replay the data. Okay, but this information I'm not going to introduce or say anything. So maybe I will create new session for this, but I recommend you to go to ROS Wiki to find out more about it. Okay, so you have a complete tutorial to tell you all this, right? And then another 4 things that important is like today I actually show you the publisher and subscriber. So this is the fundamental communication tools in ROS to let you write the communication between the nodes, which is I can see that 80% to 90% of your development will be related to this. But the communication in ROS is not just this one format. It actually got a lot more. Okay, it got 4 ways for the communication. Another one is parameter server, which is you can have a predefined variable value that this value can change when you run the same code in different conditions. For example, like you have the same navigation, but the parameter for robot A, robot B, robot C might be different, right? So this is how you communicate. And also this parameter can be queued dynamically when you do the operation. Then the third one, this one you might use this for about 20 to 30% of development, I guess. It's a service. So the services, which is you have a client and also you have a server, is very similar to publisher and subscriber, but this one, it requires a request. So publisher, node B, no need to request node A to publish or to get certain things. But for this one, for services, when 2 nodes, one need to request another node to give some services, then only the communication can be done, right? So you need to request. So, and usually these services comprise of more complicated process, not just a single data. But then actually you will use this, but you won't be writing this. It's a combination of a lot of processes. Okay, but yeah, for the current moment, I don't want to make you confused or make things complicated. So these are 4 ways of communication in ROS that later on you might slowly want to know more. Okay, but for today's class, please focus just on the first one, and the rest is for your reference that you can find more information. Right. So that's the end of my first session. I will take a break. Okay, so I will take about 10 minutes. So don't log out, all right? Don't log out and don't leave this. Okay, our session will continue, but I will take a break about 10 minutes for you to come back at 11. Now it's 11:10. So come back at 11:20. Okay, then I'll show you the code part. All right. Okay, so I will mute my mic. You can ask questions, right? Then I'll try to look at the chat while we go for the second session. All right, and also now is the time that you want to open up, try the code and so on. Sorry, the terminal command and so on just now that I showed you. Okay, so I'll give a break for 10 minutes. So we'll resume. So don't log out, just keep this as this it, and we will come back at 11:20. All right. Okay, so I'll pause here. Okay, so let me. So yeah, you can go, and I will try to answer the question in chat.
Excuse me.
Or you can actually turn on your mic to ask me questions.
Hello there. Okay,
yes, yes.
I just want to know that whether I should prepare my PC or Linux system to run this ROS. I mean, will you give us an introduction that how to practically use ROS? Thank you.
I can't really hear you clearly because I think like the audio is not really. But do you ask like do you need what system? I can't hear you clearly. What the code just now? Okay.
Am I audible now? Am I audible now?
I don't know why, but maybe it's the is the internet connection. I can't hear you clearly. Sorry. So can you like type it in the chat, group chat? Okay. So for Michael, yes, the session we record the session and we will post up the recorded video after that. Yes. And for Cairo, yes, no worry. Yeah, you can watch the recording after this. Okay. So for the rest, I have 42 in the list. Sorry, not this, but everyone. Please sign up, put down your name in the, okay, yeah, it's good. Okay, so everyone return your name, it's good. Yes, so please, I just want to check to make sure that everyone can hear my voice and see the screen clearly. So if you can't really hear it nicely, or the screen is not, or the streaming is not good, or whatever thing, please immediately feedback to me in the chat group so that I can rectify the problem, right? Okay, so the next question is, yes, I will have the slide and the video posted on the web page after this. Okay, as you can refer to the previous two class, I have the slides and in PDF or in the Google slide form, and also I will have the video recording in Google, YouTube, embed on the web page. Okay, so if any discussion, you can still discuss using our Facebook group. Okay. Okay, I was asking that whether we should set up our computer for. Yes. Please refer to my class last week that I show you how what are the things that we need, right? So you need to install Ubuntu 16.04 and ROS Kinetic. Yes, and I will appreciate if you can get ready your system and do it with me step by step in my class. And I will do something like this for my coming class as well. So I will show you example. I will expect and hopefully you can try at your terminal as well. Okay. And after this, starting from 11:20, the effect first. Like after you run the code, what will happen? So these are the things that you can expect. Then after that, I will show you how you can write the effect. Okay, so as I said, if you are using Ubuntu 18.04 with ROS Melodic, it's okay for you to use, but I cannot guarantee you that all the examples that we will discuss after this will work at your system because we never run thoroughly all the example on ROS Melodic yet, which means you might face some compatibility issue that we cannot guarantee it will work on your terminal. Okay, but of course you can continue use, but just I cannot guarantee you that it will work in your machine. Okay, because I have set the specification that we will stick on 16.04 and ROS Kinetic is because we have a big community that tested all the code and example that we have developed to make sure that it is compatible with this version. Yes, so if you want to proceed with Melodic, you can, but you might face problem and I might not be able to help you. That would be the reality. Until, yeah, I think last week, I remember last week we actually discussed about this version thing. So my estimation is we will only we'll upgrade to Melodic hopefully next year. This year, we will stick with 16.04 and ROS Kinetic, because we need to keep compatibility with a lot of our component packages. Our example, we need to make sure everything is working with our tutorials and everything. So we have written our tutorial, we have written all the slides, everything with this version. So we need some time before we can upgrade ourselves to the new version. But 16.04 works just fine. Ask the difficulty level of this course. Okay, for this course, I am actually target my audience to be totally beginning background about anything. Okay, only thing I ask you is you need to have some basic knowledge about programming. If you know Python, that will be the bonus. But if you know C++ or any other programming language that you have a concept, what is a programming, then that is enough, right? That is what I need. You need to know what is programming and you're willing to learn, particularly Python. So as long as you have this with you, with the interest to learn, I think it's enough. So it's totally very, very beginner. But of course, if you come in and you don't know anything about programming and you expect want to learn about Python, for example, or programming, we are not going to do that. Okay, so this is not a programming class for Python or anything, but we more focus on how you want to build application for AI and robotics application. So of course, you need Python or whatever programming knowledge as a basic. Okay, any more things? Okay, I've got 1 more minute, then I will start the next one. So let me change my slide. So maybe I have to put this thing back, and I have this. So I'll switch to this one. Okay, right. So if everyone okay, I will reset the recording so that I have a first part and part. Right. So I hope you can hear me. Let me reset the recording.